Today we're going to revisit applications of the integral problems. These are very, very frequently free response problems on the AP exam. So we just want to reinforce these different things. So our first problem, we have a graph here. And the particle moves along the x-axis. Its initial position, and always pay attention to that kind of information, is 4. The graph represents the velocity. So we're asked for the displacement from 0 to c and total distance traveled from 0 to t. Displacement is the difference between where you start and where you end. Total distance is going to include any back and forth distances. So for example, if you drive to school and then you drive back home, your displacement is going to be 0, but your total distance traveled is going to be all the distance from your house to school and then school to your house. So for this one, displacement, we're going 3 to the right, 5 left, and then 8 to the right. So we're going to just do 3 minus 5 plus 8 is going to give me 6. Total distance, though, is going to be 3 plus the 5 plus the 8. So that's 16. Okay. When does the particle move to the left and when does it move to the right? Okay, our next problem, a particle moves along the x-axis so that its velocity, t is greater than 0, so again, pay attention to any information like that, is given by, and I rewrote it over here, v of t equals 2t squared minus 10t plus 12. So when is the particle moving to the right? When is it moving to the left? So we're going to have to do some number charts here. Okay, so first thing I'm going to do is factor. So I factor out that 2. So then this is going to be 2 times, this is going to factor to t minus 2 times t minus 3. So we can do a number line chart here. Bend a bit. Okay, I'm going to start each of these at 0 because we do have that condition. This one's going to be 0 at 2. This one's going to be 0 at 3, so my velocity is 0 at both of those. And then we're just looking for positive and negative. So t minus 2 is going to be negative before 2 and then positive after. Same here with this one. So then here I've got a negative times a negative. So that's going to be positive, positive, negative, and positive, positive. So from that we can answer the question of when is it moving to the right and the left. So it's moving to the right from 0 to 2, and then when t is greater than 3, but we have this condition here. Okay, that it's when between 0 and 3. So between 0 and 3, it's only moving to the right from 0 to 2 because v of t is greater than 0. It's moving to the left when our velocity is negative, so that's going to be from 2 to 3. Because our velocity is less than 0. Okay, when is it at rest? It's at rest at those 2 zeros, so at 2 and at 3. Because the velocity is 0. Okay, where is the particle speeding up on this interval? So we can tell if it's speeding up if velocity and acceleration have the same sign. So a of t is going to be the derivative, so that's going to be 4t minus 10. So that's going to equal 0 at 10/4 or 5/2 or 2.5. This is our acceleration. So it's 0 at 2.5. It's going to be negative before then and positive after that. So we're looking for any locations where they have the same sign. So from 0 to 2, this is positive, this is going to be negative. From 2 to 2.5, they're going to both be negative. Okay, which means it's going to be speeding up there. Okay, after 2.5, this is positive to 3, the velocity is negative. So this is the only occasion, and our justification is that v of t and a of t are both negative. Okay, what is the displacement on the interval? Displacement is just going to be the integral. On the graph before, we just used the area. Here we're going to use an integral. So it's going to be the integral from 0 to 3. Okay, which you can use your calculator or just do a simple power rule. I'm just going to go ahead and jump to the answer is 9. Total distance traveled, however, we can't just do that because in this arena, or in this travel, he goes positive, then negative. So we have to break it up into two different integrals. So looking at our velocity from 0 to 2, he's moving to the right. Okay, and then from 2 to 3, the particle's moving to the left. So we're going to add the opposite of the integral from 2 to 3. Okay, if you were to do this integral, you're going to get a negative value. We just want to turn that into a positive value. Okay. For this one, you're going to get 28/3. This one, you're going to get a negative 1/3. So then the minus makes that a plus. So this ends up being 29/3. So when you're asked for total distance traveled, just take into account any back and forths that happen. Okay, our next problem. At time t is greater than or equal to 0, a particle moving along a curve in the xy plane has a position xt, yt with velocity vector cosine t squared e to the 0.5t. And then at time equals 1, the particle is at the 0.35. So we're going to find the x and the y coordinates of this particle. So these application problems are almost always calculator active problems. So knowing how to use your calculator to help you out and to speed yourself along is crucial. So what I automatically do is dump the two equations into my y equals. That way I don't have to keep retyping them because we've got 5 different parts to this problem. So I'm going to just label this as I put this one in my y1, I put this one in my y2. All right, so finding the x coordinates and the y coordinates. We don't have a position vector, but we have the velocity vector. So for my x coordinate, we're using this. Okay, so we're going to use the fundamental theorem of calculus. We know the particle's position at 1. We're trying to find the position at 2. So if I do the integral from 1 to 2 of cosine t squared, that's going to give me the position at 2 minus the position at 1, right? The integral of velocity is position. Well, this is what we're solving for. So we're going to add this over. So x of 2 is going to be the position at 1 plus that integral. So that's going to be 3 plus, we'll use the calculator for that part. So we'll do alpha f2, the integral from 1 to 2. Now if I do alpha and then f4 is where all those y variables are stored. I just dump that in there. We get that value, so I'm just going to jot it down for now. 0.443, and then we're adding 3 to that. So that's going to be our x coordinate. Always use 3 decimal places. You can use more, but if you use less, then you're going to get points off. The y is going to be similar, so we're going to go from 0 to 2 of e to the point 5t is going to give me the y value at 2 minus the y value at 1. Okay, so I'll just do this one all at once. My y1 is 5, and then we're going to add that to the integral from 1 to 2 of y2, and we get 7.139. Okay, our next problem, for 0 to 1, is there a point on the curve at which the line tangent to the curve has a slope of 2? And what is the, at what time is that? Okay, slope is always, always, always dy dx. Well, in this case, that's going to be dy dt over dx dt, or in this case, our two equations. So this is just going to be e to the 0.5 t over cosine t squared. So we're wondering, does this equal 2 at some point between 0 and 1? Again, the calculator is our friend here. So here, I'm going to unhighlight this one. I'm going to unhighlight. I don't want to graph those. Here, I'm just going to put y2 over y1. Okay, that's going to be my slope. Then I'm going to add another line at 2. For my window, I'm going to go from 0 to 1, because that's the only values I care about. If it crosses at some other place, I don't care. And then in my y values, we want to see 2. So maybe go from 0 to 4. Okay, so there is a point where the slope is equal to 2, and that's going to be right there. So you're going to calculate the intersection. Enter, enter, and you can guess, or you can just hit enter. And we get 0.840. Okay, at what time is the speed of the particle equal to 3? So speed is the square root of dx dt squared, so cosine t squared plus e 0.5 t squared. And we want to know where that is equal to 3. Again, we're going to use the calculator. So I replaced the slope formula with the speed formula, so the square root of y1 squared plus y2 squared. And we want to know where it equals 3. For my window, my y's are fine, but I'm going to go ahead and extend out my x's. Okay, and our graph looks like this. So here's our location. So again, we're going to calculate the intersection. And we get uh, 2.196. Okay, the total distance traveled from t equals 0 to t equals 1 is going to be the integral from 0 to 1 of the speed deal. Okay, well, I have that stored in my y3, right? So I'm just going to do the integral from 0 to 1 of y3, which gives me 1.595. So you can see how by storing these formulas in the calculator, it makes quick calculator work. The acceleration vector, that's just going to be the derivative of each of those. So the derivative of cosine t squared evaluated. We're going to take that derivative and evaluate it at 1. Okay, but again, let the calculator do the work for us. So we're going to take the derivative of y1, and we're going to evaluate that at 1. We're going to do the same thing. So I'm just going to grab this and change that to y2. And those are our coordinates. Okay, our next one. Water is pumped into an underground tank at a constant rate of 8 gallons per minute. Water leaks out of the tank at a rate of square root of t plus 1 gallons per minute. For 0 to 120, at time 0, the tank contains 30 gallons of water. So how many gallons of water leak out of the tank from t equals 0 to t equals 3? So that's just simply going to be the integral from 0 to 3 of t plus 1. Which gives us either 4.667, which is equal to 14 thirds. Okay, how many gallons of water are in the tank at 3 minutes? Well, we have the initial amount is 30. It's going in at a rate of 8, so we've added 8 times 3 because we're going for 3 minutes. And then out is 14 thirds. So we get 148 thirds for how much is in there, and this is going to be gallons. Okay, write an expression for A of t, the total number of gallons in the tank at time t. So kind of piece together what we did. We figured it out for 3. Now how do we do that in general? Well, our A of t is going to be the initial amount plus 8 times whatever our t is, minus, how did we get this? We got it from the integral. So the integral from 0 to t, and I'm going to change the t to an x here, just so we don't have the same variable, because we want our t to be t. So that's our formula. The last question here, at what time from 0 to 120 is the amount of water in the tank a maximum? Justify your answer. This is the extreme value theorem, which says that on a closed interval, the maximum value and the minimum value are either going to occur at an end point or a critical point. So we want to figure out the end points. How much is there? So we're going to do A of 0, which we know is 30, and then A of 120 is going to be 30 plus 8 times 120 minus the integral from 0 to 120. Okay, when you do all of that math, you're going to get 103.333. Okay, we also then need to take into consideration the critical point, or points if there's more than one. So we're going to take this derivative. Derivative of 30 is 0. Derivative of 8t is 8. And then the derivative of the integral from 0 to t of this is going to be the square root of t plus 1 using the second fundamental theorem of calculus. So we're going to set that equal to 0. So the square root of t plus 1 equals 8. Square both sides. And then subtract 1. Okay, so our last one, we're going to figure out a of 63. So that's going to be 30 plus 8 times 63 minus the integral from 0 to 63. When we type this all in, you get 193.333. Okay, so that's our winner. And you can do this all in a chart, just as long as it's organized and you've shown that you've evaluated at the endpoints and evaluated at the critical points. The justifying is all of that. So it says, and then look at what it's asking. It says, at what time? So our answer is going to be t equals 63 minutes is the answer. Sometimes they'll ask for what is the maximum amount, and then that would be 193. So just pay attention to that. Okay, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by this guy here, where t is measured in hours from 0 to 8. At the beginning of the workday, we have 500 tons. So always paying attention to those little pieces of information. During the hours of operation, the plant processes it at a rate of 100. So find g prime of 5. So you would plug this into your calculator, okay, and then just do the derivative evaluated at 5. This is going to be negative 24.588. Okay, using correct units, interpret your answer in the context of this problem. Okay, so the derivative is the rate of change. So we have a rate, and we took the derivative of this. So it's the rate at which the unprocessed gravel is changing. So the rate at which the unprocessed gravel is arriving is decreasing by 24.588 tons per hour when we take the units here, which were tons per hour, and then we're looking at that rate of change. Okay, and always include the time, so at t equals 5. Okay, it says find the total amount of unprocessed gravel that arrives in the plant during the hours of operation. So that's going to be the integral from 0 to 8 of g of t. Again, you're just going to use your calculator to do this. Okay, but you want to show this part. Is the amount of unprocessed gravel in the plant increasing or decreasing at time equals 5? Okay, so what we want to look at is what is g of 5, which if we plug that in is 98.104. So it's going in at 98.4. Well, how much is it processing? Well, it's processing, and I'm just going to say out, at 100 tons per hour. So since they're processing faster than it's coming in, the amount is decreasing. The last part of this question is, what is the maximum amount of unprocessed gravel at the plant during the hours of operation? Okay, so this is, again, is the extreme value theorem. So first let's come up with an expression for our gravel, and you can name it whatever. So we have an initial amount of 500. It's coming into the plant. At the rate from that equation. And then it's being processed at a rate of 100 per hour. So first we're going to evaluate at the endpoints, which is going to be at 0, which is just going to be that 500, and our hours of operation are from 0 to 8, so my other endpoint is 8. Okay, so this gives me 525.551. Then we want to see if there's any critical points. So I'm going to take the derivative of A, which is just going to be 0 here. This is going to be g of t. This is going to be negative 100. We want the derivative to equal 0. Okay, and then I would just graph. For my window, I would go from 0 to 8 in the x direction, and then in the y, we want to be able to see 100. So maybe go from like 0 to 200 or something. Okay, when you graph this, you'll see the two graphs intersect, and that's going to occur at 4.92348. So that's our third point we want to check out. So we're going to have 500 plus the integral from 0 to 4.92348 of g minus 100 times 4.92348. When we do this, we get a value of 635.376, and this would be tons. Okay, and that's our winner. Now again, what did it say? It said what is the maximum amount. So last problem they wanted the time. This problem we want the amount. Okay, so that's the end of the notes. What I am going to do is go through, this is an actual AP problem. I want to go through the scoring guidelines. So if you're interested in that, keep watching. If you're not, then you can end the video here. So this was a problem on the 2013 AP exam. It was the first question, which means it has a calculator active. So these are the problems, and I want to go through the scoring. So the scoring for the free response is always out of 9 points. Why 9? I don't know, but that's what they've done. So I want to show you how they would have graded or awarded points on this problem. So the first one, you were finding g prime. Okay, so we found that. That value is a point. Okay, so if you did this, you get a point. Then you wanted the interpretation with units. Okay, so this is the interpretation that we found. With units, if you don't include the units, you wouldn't have gotten that point. So always pay attention to when they ask for units, that means you're going to get points for that. If they're not going to award points, then they won't make that a point to include in the problem. Okay, for this one, we just did the integral and the answer. If you didn't actually write out the integral, and this is all you have to do, you would lose a point. So make sure that you're writing out the integral, writing out whatever calculation you're doing, and then your answer. This one where we were seeing, is it increasing or decreasing? We're comparing g of 5 to 100, which we did, and then your conclusion. So we determined it was decreasing. The last part, the last one we did, was worth 3 points. Okay, and this is the chart I was referring to. You can put the 3 things in one chart. That's the justification part of it, is that you've checked your maximum endpoints and your critical points. Okay, the 3 points are considers a prime equals 0. So we did that. The answer, so if you said it's 635, you get a point, and the justification is the work shown. So that's how this problem would have been graded. So at this point, you guys can do a lot of these full free response problems. So that's all I have for applications of the integral.